Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to the video on the quadratic formula. The quadratic formula is used to solve a quadratic equation. So make sure that, one, if you are going to use the quadratic formula, it is written in the form ax squared plus bx plus c equals 0. Again, you must have an a value. B and c could be 0, a cannot be 0. If a is 0, you do not have a quadratic equation. So again, the quadratic formula is used to solve the quadratic equation. The entire idea behind the quadratic formula is so that you can actually do these without kind of thinking. It's just a formula, you substitute, you get out your answers, you call it good. So somehow they had to formulate it. I'm going to walk through how the quadratic formula was formulated, utilizing the steps from my solving quadratics by completing the square video. So in that video, I said the first thing you should do is divide everything by a. If I divide everything by a, that gives me x squared, 1x squared, plus b over ax plus c over a equals 0. The next thing I had us do is I had us move this last piece to the other side so that it would be in the special format. Then I had us divide the middle value by 2 and square it. So if I divide by 2, I get b over 2a. So when I square it, I get b squared over 4a squared. And I'm going to give this a common denominator, so I'm going to multiply by 4 and a, multiply by 4 and a. And I'll clean that up a little. This is now going to factor to x plus b over 2a. And this will be negative 4ac plus b squared with that common denominator of 4a squared. We're going to use the square root of both sides. Plus or minus. I'm going to switch the order of this. I'm going to write b squared minus 4ac, and I'm going to write 4a squared. Again, we have to fix that denominator. The denominator must not have a radical. Subtract this to the other side. You'll see it has a common denominator, so I'm just going to write it as 1 with that common denominator instead of writing it as 2 separate fractions. And there we have the quadratic formula. X is isolated. So the whole point of this was just to give you a formula so that you didn't have to do the other work. If you're prepping for an ACT or something, it's better to have this memorized. If you're in Missouri and you're using the Algebra 2 EOC formula sheet, it's right on there. However, going way back to when I was in high school, which was a long time ago, I had to memorize this using a song, and it goes to the tune of Pop Goes the Weasel. So here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'd practice that, I'd sing it, it would get in your head, you can do that, not a big deal. So we're going to look at our first example, and it's going to be 6x squared plus 7x minus 20 equals 0. Now, I could solve by factoring. I'm not going to go through the work of factoring. I'll just tell you that the factors are 3x minus 4 and 2x plus 5. If you want to see factoring, go back to my factoring video. But this does indeed have a product of that. Then we would apply our zero product property. 3x minus 4 equals 0, or 2x plus 5 equals 0. Add 4, divide by 3, over here, subtract 5, divide by 2. And we get two answers, 4/3 or -5/2. However, the point of this is maybe you don't like factoring when a is not 1. Maybe you have problems with factoring. So we're going to use this formula. Our a value is 6, our b value is 7, and our c value is -20. Signs are important with this. So x will equal -b. So since b is 7, negative b is -7, plus or minus, we have our radical. B squared, make sure you use parentheses with this. I would not want you to make a sign error. I substituted for a and c, and then it's all over to a. I do not do this all at once in my calculator, I do it in pieces. -7 plus or minus, if I type 7 squared minus 4 times 6 times -20 into a calculator, I find out it is 529. And 2 times 6 is 12. And now I actually find out whether there's a square root perfect square. And indeed there is. 529 is 23 squared. Okay, so now the plus or minus really means you have to do a plus or a minus. So with the plus, we have -7 plus 23 divided by 2, and then we'll have -7 minus 23. By 2, 12 divided by 12. Okay, -7 plus 23 is 16 over 12, reduces to 4/3. This makes -30 over 12. They both divide by 6. That reduces to -5/2. So we're getting the same two answers. But this way we just had a formula, substitute it in, it gives you the answer. It works 100% of the time. And this happens to cross the x-axis twice. Why does it cross the x-axis twice? Because our radicand, our discriminant, is greater than 0. Okay, that's a big deal, that discriminant. Okay, they gave a special vocab word to the radicand. Radicand is just the number under radical sign. They called it the discriminant. That's that b squared minus 4ac part. If you know just the discriminant, you can know a lot about this graph. Okay, again, the full formula is -b plus or minus square root, and that discriminant's what's underneath there. Okay, if b squared minus 4ac is greater than 0, if that part's greater than 0, your graph will cross the x-axis twice. Could be at positive numbers, could be at negative numbers, whatever. If that discriminant equals 0, that graph is just coming down, just barely touching the x-axis, and you're getting a double root because adding 0 and subtracting 0 is the same thing. Okay, versus here, adding something bigger than 0 is different than adding something or subtracting something bigger than 0. And if b squared minus 4ac is less than 0, your quadratic equation is not actually going to cross the x-axis. Okay? There is no real solution or two complex solutions. And we're always searching for two solutions because it was an x squared graph. there's one real unique solution. It's just a double solution. You use it twice. Technically, there's two solutions, but they're the same thing, so it's redundant. Okay? And then here, there's two real unique solutions. Emphasis on the word unique. They all have two solutions. It's just, are they unique or real or not real? Again, this works 100% of the time. You just grab your equations and you go for it. So we'll do one more example with the whole quadratic formula, and then we're going to do one where we have to identify something about the discriminant. So 2x squared minus 15 equals 4x. Let that. Okay. Again, to solve quadratics, you must first make it equal 0. And this is that b term because it's the linear part, right? It has an x, so it goes in the middle. So I'll subtract the 4x. Okay. A is 2, b is negative 4, c is negative 15. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So be very careful that this negative 4 in the discriminant is in parentheses and the squared is on the outside. Otherwise, you'll have a computer miscommunication because it will think you meant something different than you did. So your discriminant should be 136. Because it's greater than 0, this graph is going to cross the x-axis twice. Okay. Now, 136 is a very large number, and we're supposed to always reduce our radicals. So let's take a look at 136. 136 is divisible by 2, and you get 68, which is divisible by 2, and you get 34, which is divisible by 2, and you get 17. This is the wedding cake method of finding a prime factorization, because it looks like, you know, the tiers of a wedding cake. So we have 2 times 2 times 2 times 17. So we have a pair of 2's that we can fold up and put outside. If you haven't seen the video where I reduce radicals, this was the folding socks method. So because it's square roots, we're using pairs of socks. We fold them up, we roll them into a ball, and we put them outside or put them away. And this radical sign's kind of like a basket. Somehow dryers eat socks, so we have socks in the baskets waiting for their partners for next time. So this now gives us 4 plus or minus 2 root 34, because 2 times 17 is 34, all over 4. And we have 3 parts to this. We have the 4, we have the 2 root 34, and we have the other 4. And all 3 parts are divisible by 2. So if I divide by 4 by 2, I get 2. And if I divide 2 square roots of 34 in half, I get 1 square root of 34. The only way to change a radical is by folding socks. This is our final answer. We could write this 1 plus or minus 1/2 root 34 by dividing each one by 2. I find that unnecessary. I'm happy with this, but different instructors might like you to have things in different formats, so make sure that you follow along what they want. Okay, so let's look at 4x squared plus bx plus 9. Okay, what could be the value of b? What value could it have so that there are no real solutions? Okay, find b so that there are no real solutions. Now, some people might just come up with a single number. That's not what the textbook would really ask. They're going to want to know all options for b. So don't just find a single b value. I know you could go in and you could sit there and play with the graph until you found a b value to where it did not cross the x-axis. That's not what this is wanting. Okay, no real solutions happens when the number underneath the radical is negative. In other words, when b squared minus 4ac is less than 0. If we can find out when this happens, we can get this. Okay, so I don't know b, I know a, and I know c. Okay. So that's 144 when you multiply that. So when is b squared less than 144? Well, you might just say when b is less than 12. However, negative 13, if you substitute negative 13 in here, negative 13 squared is 169. So we have to remember that negatives and positives, when both squared, wind up being a positive number. So it's when the absolute value of b is less than 12. Meaning anything between negative 12 and positive 12. Any of those values, if you choose one of them, you substitute it into the 4x squared plus bx plus 9, you're going to find that the graph does not cross the x-axis. If you pick a number outside of this window, you're going to start getting real solutions. They may not be nice, pretty, they might be irrational, but you will find solutions. So make sure if they ask you to find b, you don't just give them one example, you give them all examples. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.